they're saying that we've got to a point where simply increasing the problem size isn't enough either.
A tremendous source of pressure on the need for continually more powerful supercomputing is the geopolitical landscape.
Business as usual is not enough, that you do need to do something different.
Computing technology, as we were saying, these end-of themes, has hit several walls, and the future is uncertain how to get around those issues.
From Orion X in association with Inside HPC, this is the @HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey Shaheen, as always, great to be with you.
Great to be here, Doug.
Okay, so very interesting webinar today, and we want to get a quick episode out on it. It's a new report from the National Academies of Sciences, Engineering, and Medicine. It's an analysis of NNSA's supercomputing leadership class computing needs looking out over the next 20 years. NNSA, of course, the National Nuclear Security Administration. So very heavy-duty supercomputer users, but also somewhat specialized requirements. And 3 of the authors spoke at this webinar today. And I'm proud to say, Shaheen, 2 of the 3 we have had as guests. That's Catherine Yellick at Cal Berkeley and Dan Reed at University of Utah. The only one we haven't had yet, but we should get, is Dan Myron of Caltech.
That's right. Quite proud of the podcast that we do here.
So I'd say the overall, looking out over the next 20 years, really into the mid-2030s, supercomputing needs, I think to me an underlying theme that came through is we're deep into the end of Moore's Law era. And across supercomputing, this is a theme that brought up by Bob Sorensen at Hyperion Research a few months ago. Increasingly, we're hearing these, quote, end of, unquote, discussions. It's the end of Moore's Law. It's the end of, say, copper interconnects. It's the end of this. It's the end of that. And that NNSA, the supercomputing needs they're going to have in the coming decades, really whole new approaches to supercomputing are called for.
Absolutely. So the report had 12 authors, and it was reviewed by another 11, overseen by 2 others. So a lot of the really who's who and luminaries of HPC and the academic computing and national supercomputing expertise in there. They also said that they took a 20-year time horizon to this analysis study that they had done. And a lot of what they are promoting and recommending are relevant to the rest of the supercomputing market. They are very much similar to a lot of what we have been hearing over the past couple of years. And this, I thought, was a very crisp rendition of all of that. It was really to the point and captured a lot of things. Like you said, Doug, because this was for the NNSA and they have certain special requirements, just kind of nuclear security and stewardship, that's a little bit different than what others might do, but by and large, it's very aligned.
Okay, so they had one particular slide we thought was quite interesting. It's sort of, let's take stock of where we are right now. How did we get here?
Right.
And they certainly emphasized that, as our friend Addison Snell would say, science never ends. And with that, computing demand continues to grow. It's just insatiable and relentless pressure to meet future computing demands. And as more compute power becomes available, whole new workloads will be created. But certainly, compute demand continuing to grow is a huge theme. Computing technology, as we were saying, these end-of themes, has hit several walls, and the future is uncertain how to get around those issues. Let's see, there's limited benefits of additional weak scaling. And Sheen, can you help me on weak scaling? It's a term I never can quite keep in my head.
Well, I never really liked that terminology. Sorry for those who like it. But weak scaling is when you increase the size of the problem to take advantage of additional resources that you have available to you, rather than keep the problem size fixed and try to reduce the time that it takes more and more and more.
Got it.
For strong scaling, when the problem size is fixed, at some point you're going to have diminishing returns and additional resources won't do anything. So you have to increase the size. But they're saying that we've got to a point where simply increasing the problem size isn't enough either. And that's important.
Yeah. They also invoke the theme that AI methods are having huge impact in other domains. They certainly don't view AI as a panacea here, although it'll be a contributor. And then quantum, has enormous potential, as we all know, and could take on more, specialized workloads in a complementary way. But another backdrop, and again, they didn't dwell on this, but certainly we're all fully aware of it, that a tremendous source of pressure on the need for continually more powerful supercomputing is the geopolitical landscape and the growing rivalry with China, and possibly, depending on the outcome of the war in Ukraine with Russia and so forth. So Dan Reed, one thing he said, in leadership class supercomputing, this is the best of times and worst of times. There's been tremendous achievements, but again, there's this relentless pressure to
Yes.
keep pushing the envelope, and it's always a problem.
Yeah, that's right. I think that as it relates to AI, one of the things that was interesting was how that may require new advances in mathematics and computational science. And we've talked a little bit about that. When Jack Dangara was a guest and when Rick Stevens was a guest, they both talked about new methodologies and new algorithms that they were pursuing. The surrogate model that Rick mentioned, some of the new linear algebra strategies that Jack and team were pursuing are all kind of indication of how new methodologies are emerging that are faster and just as accurate. This also came up with Torsten and Satoshi when we talked about their 12 myths paper and how kind of the precision required for arithmetic is shifting as a result of some of these new capabilities.
Yeah. Should we look at some of their recommendations, maybe in abbreviated form? Because again, I think we're pretty familiar with a lot of these themes, and how it all plays out, of course, is the key.
Yeah, let me mention what I summarized the recommendations as. Hopefully I got them right, and then we can discuss them a little bit. Because
Yeah.
the actual verbiage that they use is the kind of verbiage that you are used to seeing for government communication. They have to adopt that style for reports like this. So you read a paragraph and say, okay, what are you really saying here? Right? And those who are adept at that know it, but the rest of us need a little bit of thinking. So recommendation one is get a roadmap done by next year this time.
Yeah.
And that roadmap had better take into account all the stuff that we talked about how we got in here. Second, pursue unconventional, radical approaches for applied math and computer science and computational science, really as a result of the impact of AI and quantum computing. Both of them are pointing to novel algorithms that have yet to be devised and are being pursued. Recommendation number three is workforce, that it is already difficult for government bodies and entities to attract expertise because they're competing with hyperscalers, they're competing with technology providers who have all discovered the joys of having HPC staff in their ranks, and they are buying them. So we need to do that. That was one part of it. And the second part was, with all of this geopolitical uncertainty, access to international workforce now has complexity. So those are the three: get a roadmap, pursue unconvention, and fix workforce recruitment.
Yeah. And I don't know if you have any views on a 20-year roadmap. I mean, the roadmap is, I think, obviously, the longer the time period we're talking about, the less it's likely to be executed. I would assume it would build in all sorts of means of shifting focus, shifting strategy as they go along. But it's a good exercise to go through. It's good to bring focus to the efforts of these large organizations. But again, there would need to be flexibility built into those planning.
Yeah, definitely. 20 years is a really good time horizon because a lot of what's brewing right now is likely to either mature to usability or we'll learn enough about them to pursue some other thing and pivot. And of course, new things are going to come about. But quantum computing, just our last episode with Karen Bergman, we talked about silicon photonics, AI approaches with mixed precision arithmetic, and all of those are liable to achieve maturity well within that period. So it's a good time horizon.
Yeah, and certainly in talking with somebody like, well, there's no one like Rick Stevens, but in talking with Rick Stevens, that really the mid 2030s, he has told me that's when there could be this convergence of whole new next generation technologies could really come together. By the end of the 2030s, the supercomputing landscape could be something really powerful and quite mature.
That's right. Yeah, they did talk a little bit about symbiosis of facilities, that the computational facilities and experimental facilities are becoming more symbiotic. We've also talked about that in our podcast about how everything wants to be a computer and all these instruments want to be also a computer and an AI enabled computer. That may or may not be relevant entirely to the NNSA, but it is to a lot of other HPC sites that rely on experimental instruments in a big way. That highlights the integration of the whole edge to cloud as a single entity that you raised that doesn't get a lot of attention in this particular report, at least not highlighted in the presentation. And that is probably a lot more important for the rest of the HPC market.
This notion of the integrated research infrastructure, is that what you're referring to?
That is correct, yes. That's also a taxonomy I have read. You were saying it in our pre-show.
IRI.
Yes, right.
I found this whole notion to be just fascinating, of pooling these supercomputing resources, more modular, less monolithic, although more powerful than anything we have now. But that could generate tremendous results.
Now, one thing they raised also that was just the times that we live in, the time of crisis, but also a time of opportunity is another rendition that Dan Myron was using, is that while the current situation is that the technology is being aligned with commercial uses and not necessarily aligned with the mission of somebody like NNSA, at the same time, it has never been easier than now to build custom hardware, use chiplets with whatever configuration and combination you want to use to achieve lower cost of entry for doing something that is just optimized for you. And that's really the balance, is that there are now things you can do that you couldn't do. There are things that are moving on that are not exactly aligned, and that you have to adapt and change to take advantage of the new possibilities.
Yes. Excellent. Okay, so what would be your overall takeaway? I thought overall this was a very strong visionary exercise. I mean, the three presenters led by Kathy Yellick, really impressive. You get the sense that this ship is being guided by very smart people who really know what they're talking about. They also fully appreciate the challenges ahead.
I think the recommendation is right on, that business as usual is not enough, that you do need to do something different. And as everybody who knows me knows, one of my favorite quotes is that when things change, they're not the same anymore. So you have to, it's a kind of a Yogi Berra type of a quote, but I don't know where it comes from.
I think you made it up. I think it's original from you, Shane.
Oh, no. I did hear it from somewhere. I don't remember where anymore and who it was attributed to. But they do need a new strategy. They need a new strategy for their facilities, for workforce, for how they can customize, how they can collaborate with the industry in a way that probably puts more of the responsibility on the labs and the entities. All of those are new muscles that they need to grow. And that's absolutely great advice. It's very timely advice because the Exascale project just ended. There's still a lot of room in that process, but within the next few years, it would be a prime time to develop new capabilities. So that was really, I think, a major contribution of this body, is to just point in the right direction.
Yes. Now, in the little article accompanying this podcast episode, we're providing links to this report to get a hold of it. We recommend everyone take a look at it.
Absolutely. It's, if I'm not mistaken, it's like 75 pages. So you could have it in a short afternoon.
How long is the executive summary, Shaheen? That might be helpful. No, I'm joking.
The executive summary is pretty short. I think you can read the preface. It's just a couple of pages.
There we go. All right. Well, great to be with you again, and look forward to our next chat.
Excellent. Thank you very much, Doug. Thanks for listening, everybody.
That's it for this episode of the @HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The @HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.